There is a taxi in Greece, a 1976 Mercedes 240D, and as of last count, it had crossed over 4.6 million kilometers on the original engine. No rebuild, no replacement, just oil changes and fuel. That number is not a typo. 4.6 million kilometers. That is the circumference of the Earth 115 times over. Most engines today are considered high mileage at 200,000 miles. So how did a diesel sedan from the Carter administration last 20 times longer than that? And more importantly, are there other engines out there built to the same standard? Yes. And today, we are going through every single one of them. Before we talk about engines that last forever, we have to talk about why engines die. Because the answer is not what most people think. It is not heat. It is not miles. It is not even how you drive. The number one killer of any internal combustion engine is metal touching metal without oil between it. That is it. Bearing failure, cylinder wall wear. That is how engines die. Every other cause, detonation, overheating, neglect, traces back to that single moment when the oil film breaks down and bare metal grinds against bare metal. So the engines that last 1 million miles, they all solve the same problem. They are engineered to maintain that oil film longer under higher loads, with wider tolerances. They are built with so much extra material in the block, so much extra clearance in the bearings, so much overkill in the lubrication system, that by the time a normal engine would be calling it quits, these things are just getting warm. And here is the thing. None of that engineering is secret. None of it is exotic. It is just cast iron, conservative tuning, and decades of refinement. The manufacturers who built these engines were not chasing horsepower. They were chasing time. Let us start with arguably the most famous engine on this list. The Mercedes OM 617, a 5-cylinder, 3-liter pre-chamber diesel, built from 1974 to 1991, and the reason that Greek taxi exists. The OM 617 went into the 240D, the 300D, the 300TD wagon, and the 300SD, the first diesel-powered S-Class. In America in the late 70s, when fuel prices spiked after the oil embargo, these cars became cult objects. People drove them 200 to 300,000 miles and then handed them to their kids. So what makes the 617 different? First, pre-injection. Instead of blasting fuel directly into the combustion chamber at massive pressure, the 617 fires into a small antechamber that partially combusts the fuel and sends it into the main cylinder at lower peak pressure. That lower pressure means less stress on the pistons, the rings, the crank. Everything lives longer because everything works less violently. Second, the block itself. Cast iron, thick walls, massive bearing journals. Mercedes engineered this engine for taxi fleets and commercial operators who expected 200,000-mile service intervals between overhauls. Not 200,000-mile lifespans. 200,000 miles between major overhauls. Third, almost no electronics. The fuel delivery is purely mechanical. A Bosch injection pump. No sensors to fail, no ECU to corrupt, no throttle by wire. When something breaks on an OM617, you fix it with a wrench. The Greek taxi driver, his name is Grigorios Sachanidis. He bought a used 1976 Mercedes 240D in 1981, with 220,000 kilometers already on the clock. He used it as a taxi for the next 23 years. By 2004, the car had covered 4.6 million kilometers, and Mercedes took it to their museum in Stuttgart. He changed the oil, replaced filters, swapped engines when they wore out, and drove. The car survived. That is the point. If you want a million-mile engine and you do not need to go fast, the OM617 is the answer. The only problem? Finding one with a rust-free body. But the 617 is a passenger car engine. It makes 80 horsepower. It is not moving freight across a continent. For that, you need something completely different. The next engine on this list pulled half the freight on American highways for 2 decades, and fleets expected it to hit somewhere between 500,000 and 750,000 miles before its first major service. That is not a record. That is the minimum they would accept before signing a purchase order. Cummins. The name is almost synonymous with heavy trucking in North America, and the ISX, the inline 6X series, is the engine that cemented that reputation. Introduced in 1998 to replace the legendary N14, the ISX displaced 15 liters and made between 400 and 600 horsepower depending on tune. It went into Peterbilt's, Kenworth's, Freightliners. If you drove behind an 18-wheeler on a highway in the 2000s, there is a good chance a Cummins ISX was pushing it. And here is what the fleet data says. A properly maintained ISX, with oil changed at the interval, coolant serviced, injectors replaced on schedule, that engine is expected to reach somewhere between 500,000 and 750,000 miles before its first in-frame rebuild. Depending on duty cycle, that is the baseline expectation, not the exceptional case. The baseline. After that rebuild, most operators get another 600,000 to 800,000 miles out of the same block. The block itself, cast iron, forged steel crank, heavy-duty main bearing caps, is designed to be rebuilt, not replaced. Rebuilt multiple times. With proper maintenance and multiple in-frame rebuilds, the same ISX block can realistically cover well over 1 million miles in total service life. The block itself is designed to be rebuilt, not replaced, and fleet operators do exactly that, multiple times over. What makes the ISX last? The same principles as the OM617, scaled up dramatically, a massive oil system with a high-capacity pump. Conservative fuel injection timing that prioritizes longevity over peak output, and the kind of engineering redundancy you only get when your customers are running trucks 22 hours a day and any downtime costs thousands of dollars. Cummins builds engines the way bridge engineers build bridges. They do not guess, they overspec. But there is one documented case of a diesel engine running 1.5 million miles without a single overhaul. Not a Cummins, a Volvo. And the way they got there is different from everything we have talked about so far. Volvo trucks. Not Volvo cars, though they share a heritage. Volvo trucks out of Gothenburg, Sweden. And the D12 and D13 diesel engines are what made them a global force in long-haul freight. The D12 launched in 1993. 12 liters, inline 6, turbocharged and intercooled. The D13 followed in 2008 with better fuel economy and cleaner emissions. Both engines are known for one thing in the trucking community: they just do not stop. Volvo's engineering philosophy is almost the opposite of what you would expect from a European manufacturer. No exotic materials, no complex dual overhead cam architecture, no trick combustion chamber geometry. The D12 and D13 are deliberately old-fashioned in their construction. Massive cast iron blocks, long stroke designed for torque over RPM, and a cooling system engineered with so much thermal capacity that the engine almost never reaches its thermal limits, even in extreme conditions. There is a documented case of a Volvo D12 engine run by a fleet operator called AAA Cooper Transportation, that hit 1.5 million miles over 7 years without a single overhaul. The only thing replaced was one injector. The secret, if there is one, is stroke. A long stroke. Engine revs lower to make the same power. Lower RPM means fewer combustion events per mile. Fewer combustion events means slower wear on every moving part. Volvo optimized for the long game, literally. If you grew up in the United States, there is a good chance you already know this next engine. You just do not know you know it, because you rode to school on it every morning for 12 years. The DT-466, International Harvester, later Navistar International. A 7.6-liter inline 6 diesel produced from 1971 to 2003 in its mechanical form, with electronic versions continuing even longer. The DT-466 was in school buses, step vans, box trucks, motorhomes, and municipal equipment. It was the engine that America's infrastructure ran on for 3 decades, and the reason school districts loved it was simple. It never broke. Not in a dramatic way, anyway. You could ignore a DT-466 for longer than you had any right to, and it would still start on a cold morning and haul 40 kids to school without complaint. The architecture is pure over-engineering. 7.6 liters to make between 170 and 300 horsepower. Do that math. That engine is barely breathing to produce its rated output. It has so much displacement. Headroom that it operates at a fraction of its potential stress at all times. 500,000 miles on a DT-466 in a school bus fleet was considered normal, not impressive. Normal. Many districts ran them to 700,000 before a first major service. One more engine, and this one might be the most interesting story on the list, because it ended up powering almost everything, everywhere, and most people have never heard of it. The Isuzu 4 BD1 and its sibling, the C240. If those names mean nothing to you, here is a different way to think about it. If you have ever been in a warehouse, driven a forklift, used a construction generator, or ridden in an NPR truck, you have been close to one of these engines. Isuzu is the largest manufacturer of light-duty diesel engines on Earth. Not the most famous, the largest. They build engines for their own vehicles and for dozens of other manufacturers under license. The 4BD1, a 3.9-liter inline 4, has been in continuous production in various forms since 1980. It is still being built today. The reason it lasts is almost comically simple. 4 cylinders instead of 6, less reciprocating mass, fewer parts, a short, rigid block that barely flexes under load, and a conservative injection system that will run on fuel of questionable quality in developing markets without complaining. In industrial applications, forklifts, standby generators, the 4BD1 runs 24 hours a day, 7 days a week for years, not months, years. Fleet operators in Asia report engines crossing 30,000 hours of operation. 30,000 hours. At a conservative 30 miles per hour average road speed, that is 900,000 miles. In a forklift that never leaves a warehouse. It is the most unglamorous engine on this list, and probably the most quietly impressive. Every engine on this list so far has been a commercial diesel, something that hauls freight, runs a generator, or carries 40 kids to school. The last one is different. It sits in sports cars. It powers luxury sedans. An entire generation of car enthusiasts has it tattooed on their forearms, and it belongs on this list, but not for the reason most people think. Yes, I saved the enthusiast. favorite for near the end. And yes, it belongs on this list, not because of what the tuner community did to it, but because what Toyota built it to be before anyone added a turbo. The two JZGE and two JCFE, the naturally aspirated versions, were Toyota's flagship inline 6 engines from 1991 to 2007. 3 liters, 24 valves, double overhead cam. They went into the Lexus GS 300, the Lexus IS 300, the Toyota Supra, the Aristo, the Crown. The block is cast iron in an era when everyone was switching to aluminum. The forged steel crank is cross-drilled for better oil flow. The main bearing journals are enormous, far larger than the power output requires. The oil passages throughout the block are sized for an engine making twice the power. And that is the key. Toyota built the two JZ engines to handle forces it would never see in stock form. Which is why, when people started adding turbos and pushing it to 500, 600, 800 horsepower, the block simply shrugged. But for longevity, the naturally aspirated 2JZ is a different kind of remarkable. Lexus GS 300 with 300,000, 350,000, 400,000 miles on original engines are not rare finds on forums. They are Tuesday. Change the oil. Use genuine Toyota coolant. Replace the timing belt on schedule. That engine will outlast almost any car it was ever put into. So what do a Greek taxi, an American school bus, a Swedish 18-wheeler, a Japanese luxury sedan, and a warehouse forklift have in common? Every engine on this list shares 4 traits. First, cast iron. Heavy, old-fashioned, unfashionable cast iron. It does not crack. It does not warp. It machines beautifully for rebuilds. Aluminum is lighter and conducts heat better, but cast iron lasts longer. Full stop. Second, conservative power output relative to displacement. None of these engines are stressed. A 3-liter making 160 horsepower has a completely different internal life than a 2-liter making 300. Physics does not negotiate. Third, simple, robust lubrication. Oversized oil pumps, generous passage sizes, big bearing journals. The oil film never breaks down because the system is over-spec'd for the load. Fourth, serviceability. Every engine on this list was designed to be worked on by a mechanic with basic tools. No special dealership equipment. No software unlocks. Just wrenches and knowledge. The engineering world moved on from these principles in the name of fuel economy, power density, and emissions compliance. Modern engines are miracles of efficiency. They are also fundamentally different machines, optimized for a different goal. These engines were optimized for time, and they won. If you have made it this far, you have sat through the full case for why boring engineering beats exciting engineering every single time when the goal is survival. Drop in the comments, what is the highest mileage engine you have ever personally seen or owned? Because I have a feeling this audience has some stories. Subscribe if you want more deep dives like this. There is a video on the most unreliable engines ever built coming next, and some of the names on that list are going to surprise you. See you there.